We will wait for a few more minutes, then we will start after some time. In the meantime, do you have any doubts in the regarding the previous uh, sections of the course? Any doubt you can ask me. We have some time before starting today's interaction session. I'll be solving a few problems, but you can ask your doubts if you have any. Hello everyone, can you see my screen? Hello? Am I audible? Okay, so let's start today's session. Very good evening to all. I welcome you again to the interaction session of Atomic and Molecular Physics course for January 2023 session in NPTEL. I am Vivekananda Nayak, a PMRF PhD research scholar in the Department of Energy Science and Engineering, Indian Institute of Technology, Delhi. So today we will be covering a few problems which is based on the week 7 and week 6 lectures of the course. So we will proceed with some basic quantum mechanical ideas, because in the recent week we studied about the quantum mechanical treatment of hydrogen atom, and that results in different types of parameters. We could uh, know about different types of parameters. So basically, quantum mechanics is based on the quantity which is wavelength, like sorry, which is uh, its psi, that is wave function, and according to de Broglie principle, each material particle associated with a wave whose wavelength is lambda is equal to h by p. So or lambda is equals to h by mv. And again, also from Planck's, um, also when we deal with the blackbody radiation, then there were also results that the energy of the energy of the light is quantized, which is we write it as E is equals to n h nu, where h nu is the energy of the photon, which is quanta of light energy, and n is the integer. So basically, quantum mechanics means everything is quantized. So here the energy of the so here energy is quantized, which is integral multiple of h nu, and here h is Planck's constant, which is 6.67 into 10 to the power minus 24 to minus 27 joule into joule second inverse joule into second, sorry. And then there were like in classical mechanics, what we do in classical mechanics is mainly based on the equation which is force F equals to ma vector, and from that equation if we put force, in place of force we put m, and for a we put d square x by dt square. So this is a so when this term arises, so it results in a differential equation, and when we solve it, then we found xt. Xt is the position of a particle at a particular time t. Then after that, when we get xt, then by differentiating xt we can find velocity, then acceleration, then mass into acceleration is force, like that. So first we determine xt, and we derive all the other quantities. Similarly, in quantum mechanics, first we if we know the wave function of a state, then we can calculate different other parameters, and the parameters which are calculated, these are calculated in by the help of the operators, like in so each physical quantity here, since its velocity, acceleration, then another momentum p, like that in classical mechanics. However, in quantum mechanics, each physical quantity is associated with the operator, like the position x is written as x cap, and the momentum p, which the x component of momentum p is written as minus I h cross del by del x. So these are operators, and in quantum mechanics each physical quantity represents an operator. So again, there are also different conditions for psi. Psi needs to be normalized, like if we let me add another slide. Like if psi is the wave function, then the wave function should be normalized, like the normalization condition is minus infinity to plus infinity psi psi star. In if we're talking about one dimension, then it is one. So what we found, we know in quantum mechanics psi has no physical significance. However, the mod square of psi has significance, which is probability of finding the particle, in that region. So here mod square is nothing but psi and psi star, where psi star is the complex conjugate of psi. So this will be psi mod square dx equals to 1. It is minus infinity to plus infinity, which also tells us that the total probability of a particle to be found is unity. Like if I this minus infinity to plus infinity expands to the whole space, so in one dimension it is from minus infinity to plus infinity psi mod square dx is equals to 1. So this is the total probability of finding a particle in a space. Similarly, these are the operators. Then suppose we want to calculate the position of the particle in a state. Suppose in a state the wave function is psi. If we want to calculate the position of the particle, then it will, if we operate the x cap operator on psi, then we get the result. Then similarly, if we want to calculate the momentum, then we operate px cap operators psi, and we get the value in that state. So again, you must have heard about eigenvalues and eigenfunctions. So since these are operators, and psi can be represented in terms of matrix, like it so so we can write, if a is an operator, a, when it operates on a wave function psi and it gives a value a, and again it also gives that wave function, then this is known as the eigen value. This a is known as eigen value, and psi is known as eigen state. So the eigen value, uh, so this is the value, like when you operated x cap on psi, this value will give a position. If it is px, then this value will give us the momentum, like that. So this is known as eigenvalue equation, that is a cap psi is equal to si. And we will also solve different problems which will be based on this type of quantum mechanical treatments. So let's start with our first problem of the day. So this is the question which gives, calculate the question says, calculate the energy difference between the ground state and fast excited state for an electron in one dimensional rigid box of length 10 to the power minus 8 centimeter. Use standard values for mass of electron and Planck's constant. So we use the mass of electron and Planck's constant, and we want to calculate the energy difference between the ground state and fast excited state for an electron. So this will be mass of electron, and in one dimensional rigid box of length 10 to the power minus 8 centimeter. Can anyone tell me what is one dimensional rigid box? Anyone? So one dimensional rigid box is a one dimensional box, like it has only one dimension, it is x. In a box, if this is length 10 to the power minus 8 centimeter, so this length is 10 to the power minus 8 centimeter, and these are the two walls of the box where the potential is infinite, and in between the wall here the potential is 0. So this one dimensional rigid box has a potential of the form Vx equals to, suppose this is 0 and this is L. Vx equals to 0 from x equals to 0 to L, and Vx equal to infinity for other values of x. So this is a one dimensional rigid box, and you must have gone through the lectures of the week 6, where we can calculate the wave function of the particle in a box and the energy of the particle in a box. So uh, when you introduce the boundary, like from 0 at 0 and at L, the wave function is the at 0 and at L the potential is infinite, and one of the properties of wave function is when the potential tends to infinity, the wave function tends to 0. That is, where the potential is infinite, a particle can't exist in that region. So here that is psi x at x equals to 0 is 0, and psi x at x equal to L is also 0, because potential at these points 0 and L is infinity. So since the potential is infinity, a particle can't be present at that point, so the wave function is also 0. So here we want to calculate the energy difference between the ground state and fast excited state for an electron. So we know that for a one dimensional potential rigid box, the uh, wave function of the particle is given by psi n x is equal to 2 by L root sine n pi x by L. So this is the wave function of the particle. This is the wave function of the particle in a potential box of length L. Here L is what is given. L is 10 to the power minus 8 centimeter, and here we want to calculate the energy difference between the ground state and fast excited state. So also the energy of the particle in state n is given by n square h cross square pi square by n square h cross square pi square by 2m L square. So this is the energy of the particle in a state n. So the formula gives n square h cross square pi square by 2m L square, and if we put h cross is equals to h by 2 pi in this formula, what we get? En equals to n square h square by 8 m L square, where n is 1, 2, 3, 4 up to other integers, and n not equals to 0. Can anyone tell me why here n is not equals to 0? Anyone? No, no, energy is quantized, that's okay. But here n can't be 0 because this is the wave function psi n x, which is 2 by L root sin n pi x by L. So when you put here n equals to 0, then sin 0 will be how much? Then sin 0 will be 0, because if we put here n equals to 0, then sin 0 will be 0. Since sin 0 will be 0, then psi will be 0. That is, the wave function associated with the particle is 0 and the particle is not in that state. So for a particle, n equal to 0 is not possible, because for n equal to 0, the nature of the wave function is such that wave function will be 0, and it is not like in quantum mechanics where the wave function is 0, particle can't exist there. So when we are talking about the states of the particle, then n starts from 1. So for first state, that is the ground state, n equals to 1. So u1 is how much? U1 is h square by 8 m l square. Similarly, E2 will be how much? Anyone? E2 will be how much then? If we put n equal to 2, 4 h square 8 ml square. So, in question what is given, we want to calculate the energy difference between the ground state and fast excited state. So, ground state energy is how much? E1. We can write E1 to be, suppose this value we take as E0, that is the ground state energy. Then E2 will be how much? E2 will be 4E0. So the difference between the difference in energy between the two level, because this one is ground state and this one is excited. Let me draw a diagram. So if this is a one dimensional potential box which is 0 and it is 10 to the power minus 8 centimeter as given in the question. So for n equal to 1, this is n equals to 1 and it has some value, it is not 0. In quantum mechanics, energy can never be 0. So particle has some, so if particle has the lowest energy of the particle is non-zero, and that is also known as 0 point energy or the ground state energy. So here n equal to 1, it is E0. N equal to 2, it is, if here n equal to 2, it is 4E0. For n equal to 3, it is 9E0. Like that. So here this is E0 and the separation between them is then 3E0. And here separation between 2 and 3 level will be 5E0. So as we go to higher states, then the separation between the states is increasing. Can you tell me in case of hydrogen what we are getting? When we are talking about different energy levels of hydrogen, then what are the separation between, what are the nature of separation between different levels of the hydrogen atom? Was that the same, was that the same like this, or that was different? Anyone? Actually in the session you should interact, because you are not interacting, then you may be missing different things. Because if you start asking questions, then I will try to explain you in the best way I can explain you. So you should ask question and you should also respond to the discussion, then only it will be enjoyable. So in hydrogen what happened, the as we go on increasing, the energy levels were decrease, the distance between the energy levels were decreasing, because in hydrogen, what was the energy of the n state of hydrogen, n state of electron in a hydrogen atom? Anyone? So this is the energy. So if we put all the values, it was coming out, how much it was coming out to be 13.6 electron volt. So here you can see the energy En is inversely proportional to n square, but here in this case the energy En is directly proportional to n square. So in case of particle in a one dimensional rigid box, the separation between the two energy levels goes on increasing as we increase the n value. However, for hydrogen, the separation between the two energy levels decreases as we go on increasing the value of n, because here in that case also we are starting n is equals to 1 2 3 4 like that. N was not 0, because when n equal to 0 it will be how much? Infinite. So this is the relation. So from these discussions what we found, the difference between the ground state energy and fast excited energy level is 4E0 minus E0 equals to 3E0, that is 3 into h square by 2m by 8m L square. So the value of h is how much? The value of h is 6.67 into 10 to the power minus 27 joule into second, and mass of electron Me is how much? 9.1 into 10 to the power minus how much? Minus 31 kg, and here L is given 10 to the power minus 8 centimeter. That means it will be 10 to the power minus 10 meter. So put all the values here and calculate what will be the difference. So if you can calculate this value, then we can say that this will be the ground state energy. So please put the values and calculate. I will wait 5 minutes to. I will wait 5 minutes for you to calculate. Then we will proceed to the next question. So please calculate and tell me. It will be better if you tell in electron volt, because generally if you are talking about electron, then the convenient unit of energy is electron volt. Is this joule or electron volt? No, it should be 38 electron volt. So if we put the values, so if we put all the values, we will get it to be 38 electron volt. So 3 into 38 is 114 electron volt. So this is for electron delta, the difference in energy for electron. So if we place an electron in a one dimensional rigid box of length 10 to the power minus 8 centimeter or 1 angstrom, then the ground state energy will be 38 electron volt and the fast excited state energy will be 38 into 4, which is 152 electron volt. So the difference between the two energy levels is 152 minus 38, that is 114 electron volt. So is this clear to all of you? Is this clear to all of you, or I should explain it again? So can you tell me what should be the difference in energy between the fourth and fifth excited states? If a electron is sorry, fourth and fifth, so it will be 9 in 0 because for fifth level, so if we take the fifth level, then it will be 5 square, that is 25 E0, and the fourth level will be 4 square, that is 16 E0. So it will be 9 E0. So the difference between the fourth excited state and third excited state is 9 E0. So we can proceed to the next question. And this question says, calculate the probability of finding a particle trapped in a box of length L in the region from 0.45 L to 0.55 L for its ground state. So we know, in order to calculate probability, what should we do? It is given the particle is in a box of length L. It is the similar case, that is, this is the box and the length of the box, in the previous case the length of the box was given to be 10 to the minus 8 centimeter. However, in this case the length of the box is given is L. So like in the previous question I told about the wave function, because in order to calculate the wave function, in order to calculate the probability of the finding particle, then we should first determine the wave function, and we know the wave function of the particle in a one dimensional potential box is 2 by L sine sine n pi x by L. So this is the wave function of the particle, and this 2 by L term comes as a result of normalization, because if this 2 by L term is not here, then if we integrate the psi nx and psi nx mod square from 0 to L, it will not be 1 then. So wave function, the normal, this is the normalization condition. So in order to, from this condition, if we put here 0 to L, then we can calculate the normalization constant, and this is the normalization constant which is 2 by L. So the wave function of a particle in a state, in nth state, is 2 by L sin n pi x by L. And we know the probability of finding a particle is given by psi star dx, where the limit of the integration will be the limits. Here it is given, we want to calculate the probability of finding the particle in a box in the region from 0.45 L to 0.55 L. So it is 0.45 L and it is 0.55 L. So if this is the ground state, then what should be the form of the wave function? How the wave function should look like for this type of potential? We can see it is sine, so it will be like that. So again, for n equals to 2, it will be like that. For n equal to 3, it will be like this. So it is sine pi x by L. Then we if we call sine 2 pi x by L, then the form of the wave function will be like this. It is for n equal to 1, it is n equal to 2, it is n equals to 3. So if we calculate the this quantity, that is psi star dx equals to, and we will take integration from 0.45 to 0.55 L. Suppose this is L, then this will be 0.5 L. So we want to calculate between these two ranges, 0.45 L to 0.55 L. That is, in this region, what is the probability of finding the particle? So in order to find the probability of the particle, we should multiply the wave function with its complex conjugate. So can anyone tell me, if psi is this, what should be psi star? Anyone? Yes, because since the wave function is real, then the complex conjugate is same as the wave function. So psi star will be again 2 by L sine n pi x by L. So if we calculate this value, this will give us the probability. So in order to calculate this value, we will integrate from 0.45 L 0.45 L to 0.55 L, and here 2 by L root square and sine square n pi x by L dx. How we will calculate this integration? We will take 2 by L outside. Suppose this is from x1 to x2 we took. It will be sine n pi x by L, sine square n pi x by L. So we can write it 1 by L, and we can put it 2 sine square n pi x by L. 2 sine square x, what is the formula for 2 sine square x? Anyone? It is 1 minus cos 2x. So we'll put it 1 by L x1 to x2 x1 to x2 1 minus cos 2n pi x by L dx. Then 1 by L will be outside. 1 into dx is dx and the integration of dx is x. So this will be x whose value will vary from x1 to x2 minus the integration for cos is sine and it is 2n pi x by L will be the it will be its reciprocal, that is L by 2n pi, then cos, sorry, for cos it is sine 2n pi x by L. It is also from x1 to x2. Here in the question what is given, calculate the probability of finding a particle for 0.45 L to 0.55 L for its ground state. So what should be the value of n for ground state? For ground state it will be 1. So if we put here n equals to 1, this n will be equals to 1. Then here we can put x2 minus x1, so 0 point. So we can put here x1 is 0.45 L and x2 is 0.55 L. So if we put all these values, 1 by L, 0.55 minus 0.45, so it will be 0.10 L, and this L by 2 pi minus L by 2 pi sine, here if we put 0.55 L in x2, so L gets cancelled out. 0.55 L means, so if we put here 0.55 L, it will be sine 1.1, sine 1.1 minus, if we put here x1 is equal to 0.45 L, then L gets cancelled out. 2 into 0.45 is 0.9. It will be 1.1 pi and it is sine 0.9 pi. So this L and this L gets cancelled out. So it will be 0.10 minus 1 by 2 pi into sine 1.1 pi is how much? Sine 1.1 pi is minus 0.30 minus sine 0.9 pi What will be sin 0.95? It will be minus, it will, the value is same, but it is, since 1.15 is negative, 0.95 will be positive, so minus of positive is negative, so it is 0.30. So we calculate, it is 0.10 minus 1 by 2 pi is 6.284, and this is minus minus 0.6. So it will be 0.10 plus, because this minus minus is plus, 0.60 by 6.284. It will be 0.095. So it is 0.195. So if you convert it into percentage, then it will be how much? 19.5%. So this 19.5% is the probability of finding the particle in the region 0.45 L to 0.45 L to 0.55 L. So in this region, the probability of finding the particle is 20%. So you can see, uh, if this is 0 to L, it is L, but here it is given 0.45 L to 0.55 L, so it is 0.1 L. So if the probability is 100%, then in the region 0.1 L, it should be 10%, because 0.11 L is the 1/10 of 100%, so this should be 10%. But since the wave function of the particle is such that you can see the amplitude of the wave function is here less, but here it is very high. So due to that reason, when we are taking the square of the wave function, then the value between 0.45 to 0.55 L is more than its, what it should be. So the probability of finding the particle is 0.5% between the distance 0.45 L and 0.55 L. So is it clear to all of you, or I should explain it again? So in the, so what we do here, we know the, for a particle confined in a box of length L, the wave function of the nth state is given by, the wave function of the nth state is given by 2 by L sin n pi x by L, where n is the state, n is the state. We start from n equal to 1 2 3 4 like that, and n is, and L is the length of the box, and for ground state n equals to 1. So according to quantum mechanics, the probability of finding a particle between 2 points is given by the integration with ranges, the with range, the 2 point being the range, and its product of derivative, product of the wave function with its complex conjugate. Since the wave function of the particle is real, the complex conjugate is same as the wave function, and if we multiply with the complex conjugate and integrate from the given value, that is 0.45 L to 0.55 L, we obtained that the uh, probability is 19.5%. So it gives, if a particle is in a box at ground state, the probability of finding the particle will be 19.5% between 0.45 to 0.55 L. If the question was given find the particle, find the probability of the particle between the 2 points 0.25 L to 0.75 L, can anyone calculate and tell me? Please calculate and tell me. So, if the question was the probability from 0.25 L and 0.75 L, what should be the probability? Same here, what we will do, this is this 0.10 will be then 0.50, this will be, since x2 minus x1 in that case was 0.1, but here x2 minus x1 will be 0.75 minus 0.25, so it will be 0.5. This is 0.50, so it will be 0.50 minus 1 by 2 pi will be there, because 1 by 2 pi was present in the function, and this will be, it was 2 x in 2x, so this x1 will be 1.5 pi and another will be 0.5 pi, so it will be sine 1.5 pi minus sine 0.5 pi. So what is the value of sine 1.5 pi? Sine 1.5 pi is 0, this will be 0.50 minus 1 by 6.284. Sine 1.5 pi is minus 1, minus of sine pi by 2 is 1, minus of 1, this will be 2, so it will be 0.50 plus 2 by 6.284. 2 by 6.284 will be how much? So 0.50 plus 0.32, it will be 0.82, and the percentage will be 82%. So similarly, what we saw, if this is L, then this is 25 and this is 75, this is 0.5, this is 0.5, this is 0.5 L, but the probability is very greater than that of the 50%, because here if we, if this is the, if this is the wave function, then the amplitude of the wave function is more in this region. Also, if we, these are for wave functions, this is wave function, but if we talk about energy, if we talk about probability, if we talk about probability, the probability curve will be sine square, so it is this, and here it will be like this. So in the first state, here the probability of the particle at the middle is large, but here the probability of the particle at the middle is very small, because here the particle will not be present. So this is the problem. We calculated the probability of finding a particle in a box of length L between two particular values of length. So if like this, if there are any any type of value is given in the problem, you can calculate accordingly, because you only need to know the wave function of the particle in that state, and you can calculate using the probability condition of the wave function. Like this is the probability condition, and with using this you can calculate the probability of finding the particle. So the next question is, chromium has an electron configuration of 4s1 and 3d5. What are the ground state L and S values? So this question is from LS coupling. For 4s1 and 3d5. So here, if we arrange the electron, there is a technique to calculate the ground state only. If the questionnaires calculate the possible number of states, then we will approach in the way that we discussed in the previous session. But here we will calculate only the ground state, because we want to know the ground state L and S values. So this is 4s and this is 3d. We know d has 5 subcells. So 4s there is only one electron, and in 3d 5 there is 5 electrons. Since all the electrons have identical spin, then we know that for electron spin is how much? Electron spin is half. So for these 6 electrons, what will be? So S, since S is half, Ms will be plus minus half. For up spin, Ms is plus half, and for down spin, Ms is minus half. So this is here all have up spins. So this is the summation of all ms will be how much? 1.2 plus 1 by 2, 6 times, so it will be 3. So what we found, ms equals to 3. We know for s equals to half, it has how many values? 2s plus 1 values, which goes from minus s to plus s. So if ms is minus half or plus half, then it belongs to s equal to half, where ms is the maximum value. Similarly, here in this case, if ms is 3, that is the maximum value of ms is 3, then it should corresponds to which value of s? Can anyone tell me? Like in this case, ms half corresponded to s equals to half. Since ms here is 3, that is plus 3, what should be the value of s corresponding to that ms? It should be 3, because uh, did everyone understand how it is 3? Anyone? Please respond to my question. Is it, is everyone clear about this? How we get from ms equal to plus 3 to s equal to 3? Because here there are 6 electrons. One electron here. One electron is present in s subcell and 5 electrons are present in d subcell. Since it is half filled and it is also half filled, so the spin of the electron will be up spin, either up spin or down spin. So the distribution of electron is such that all the electrons are in up spin state, So for up spin we have uh, ms is plus up, and for down spin ms is minus up. So if we add the individual ms values of each electron, then it will be plus half plus plus half plus half, like for 6 electron there will be 6 halves, that will be 3. And we know that for a s value, ms has 2s plus 1 values, which ranges from minus s to plus s. So since we are adding the values of ms, this should be maximum ms, and this maximum ms is plus 3. Since this is plus 3, then what should be s? Since the s value is for a value of s, ms is minus s to plus s. So for ms is equal to plus 3, the value of spin s equals to 3. So for chromium, the ground state s is 3. This s is 3 we obtained. Then we will obtain the value of L. Similarly, if we take the configuration, this is 4s state, it is 4s1, it is 3d. So for s, what is the value of L? For s orbital, what is the value of L? It is 0. So for s, L is 0. If L is 0, what is ml value for this state? Ml is again 0. And for this state 3d, L is how much? For d, what is the value of L? It is 2. So the ml values will be from minus 2 to plus 2, that is minus 2, minus 1, 0, 1, 2. So if we, here it is minus 2, minus 1, 0, 1, 2, and it is 0, because L for S, L equal to 0 and ml is equal to also 0. So if we like for spin, we added all the spins individual ms values. Here we will add individual ml values. So the summation of all ml values will be how much? 0, this 0, then plus minus 2 plus minus 1 plus 0 plus 1 plus 2. It is how much? The total sum will be 0, and this is the maximum value of ml. We know that if ml is 0, it corresponds to which L value? If ml is maximum and the value of maximum ml is 0, then what should be the value of L? Anyone? The value of L will be 0. So this is the value of L we get, and this is the value of S. So the value of L is 0. So for chromium, whose electronic configuration is 4s1 and 3d5, its ground state has L equals to 0 and S equals to how much? 3. Then what should be its spectroscopic notation? 2s plus 1 Lj. J will be how much? What will be the value of J? It will be 3. Then for S equal to 3, 2s plus 1 is and 7s it is 3. So the spectroscopic term for the ground state of chromium is 7s3. Everybody got it? The value of L is 0, value of S is 3, and J, we know J is L plus S to L minus S. Since L is 0, J has only one value, that is 3. Sorry, here it should not be 3. The spectroscopic term will not be 7. This is not correct. This is not correct. This should be the um, uh, value of L, S, and J. L is 0, S is 3, and J will be 3. So we will proceed to the next problem. The problem is use wants to calculate the ground state L and S for iron, that is Z equal to 26. So if the ground state, if the atomic number for iron is 26, then what should be the electronic configuration of iron? Argon 18, then the remaining will be 4s2 and 3d6. The remaining 8 will be arranged in 4s2. In 4s it will be 2, and in 3d it will be 6. So we will calculate the value of L and S for this state. In previous, like in the previous case, we calculated for 4s1 and 3d5. Here we will calculate 4s2 and 3d6. So for 4s, it is 4s. There are 2 electrons here, so it is filled completely. And for 3d6, there is provision of 10 electrons in 3d, but 3d has 6 electrons. So 1, 2, 3, 4, 5, 1. So these are the 6 electrons. Here there are 2 electrons. Here it is 6 electrons. So for this, what should be S? Sorry, Ms. Ms will be plus half plus minus half, because here there are 2 electrons, and for both the electrons, the Ms value for one electron Ms will be half, and another electron Ms will be minus half. So it will be 0, and here it will be this will give you 0 because it is plus half minus half, and this is all half. So half 4 times, when you add it, it will be 4. That is, sorry, it will be 4 into 1 by 2, that is 2. So this is 0 and this is 2. So these two add up and give the maximum value of Ms is, sorry, these two add up, and the maximum value of Ms is 2, and this value of Ms2 corresponds to S equals to 2. So the for ground state of iron, the value of S is 2. Similarly, please can you tell me what should be the value of L in this case, because this is the configuration. So please calculate and tell me what is the value of L in this case. So it will be 2. So we can calculate like in the previous problem we calculated. So for this ml is 0 and 0. So total ml will be 0. For it minus 2, minus 1, 0, 1, 2. But here there are 2. So there will be 2 minus 2. This all when add up it gives 0. Their sum is 0. So the overall sum will be, the sum of ml here will be minus 2. Minus 2 plus 0 is minus 2. So total maximum value of ml will be minus 2, and the maximum value of ml minus 2 corresponds to L value, L equals to 2. So we got S equal to 2 and L equal to 2. So here what I am saying, it is 7, sorry, yes, yes, you can ask. Here, here, here actually you see, it is one electron. If one electron is present here, if it is half filled, like each one have a single electron. So here, since this electron, it is only one electron, then we take minus 2, minus 1, 0, 1, 2. When you add, we add all these numbers single time because only one electron is present. But here, since at minus 2, the electron is, that there are two electrons, because when we, according to Pauli's exclusion principle, no two electrons can have all the four quantum numbers same. So this is the method of arranging the electrons. So first we will arrange electrons from, we arrange electrons in only one electron in each subcell, and then we will again start arranging from the start. So here, since there are 6 electrons, So for Ml equals to minus 2, there are 2 electrons and all the remaining have 1 electrons. So when you add, we add minus 2 two times and other minus 1 0 1 2 only single time, because corresponding to these states there are only one electron present, but here for minus 2 the electron is there are two electron which are present in minus 2. So when you add, minus 2 will be added twice. So minus these all the above combination it gives 0, as we had calculated it gives 0. So for a half filled cell, the value of the summation of ml is 0, but here it is not half filled, it is more than half filled. So here the value of ml is not 0, it is minus 2, and this minus 2 corresponds to L equals to 2. So we get here we got S equals to 2 and here L equal to 2. So for ground state it will be S equal to 2 and L equal to 2. Is it clear now? Okay. No, no, not like that. No, no, not like that. If there are, suppose we will take another example. So suppose this is D subcell, and here we take, suppose we take 3D8. We take 3D8. So for 3D8, what will be the configuration? Each one will be first given a single electrons. Then the remaining three electrons will come in these three subcell. So it is minus 2, it is minus 1, it is 0, it corresponds to 1, it corresponds to 2. So here what we will add, minus 2 two times, minus 1 two times, 0 two times, 1 single time and 2 single time. Then the sum will be how much? Minus 2, minus 2, minus 1 plus 0 plus 0 plus 1 plus 2. So it will be how much? Plus 2 minus 2 cancels, plus 1 minus 1 cancels. This will be minus 2 and minus 1, it will be minus 3. So this minus 3 will be corresponding to how much? L equal to, if this is ml, ml is minus 3, then L must be 3, because the maximum value of ml corresponding to L is 3 or minus 3 or plus 3. Because we know that for L, ml can have values from minus L to plus L. So since this is minus 3, so L value is 3. Now is it clear? Okay, so good. You should ask doubts if you have any doubts. Only then the class will be more interactive. And main aim of this session is to solve your different problems, and also you should learn how to solve problems in assignments. So this type of questions we will get in net get exam or jam exam if you are giving. So this type of question generally comes. So here you must remember I was writing 7. How much it should be? 2s plus 1 lj. 7s. Here how much? 7s 3. Is not it? So this will be ground state. But generally if it is 7, S should be, if this is 7, the value of J should be 7 numbers, because as we are writing it is, if it is 2p, then 2p half will be possible and 2p 3 by 2 will be possible, but out of these two only one can be ground state, only one can be ground state. So here it is 7, the ground state is 7, ground state is 7s3, but corresponding to this 7, that is we in this set there are 7 states, but the ground state is 7s3. That is, for ground state the j is 3, but there are 7 such states which corresponds to this multiplicity 7. So now we get it. See, it is given ground state, so there should be only one ground state, because there can't be more than one ground state in a system. Should we proceed to the next question then? Or anyone have any doubt? They can ask me. So here for Z equal to 25, we first arrange the electron in its cells. Then we calculated individual ms and individual ml, and adding them we calculate the value of s and l. So value of s is 2 and value of l is 2. So what should be the ground state then? Can anyone tell me what should be the spectroscopic term of the ground state? No, it is not s, because for l equal to 2, it is how much? For L equal to 2, it will be D. And the value of J here, what should be the value of J? No, here it will not be 4. Because according to Hund's rule, the value of J for ground state, the value of J is L minus S for the value of J is L minus S mod for less than half filled, and the value of J is L plus S mod for more than half filled. Sorry, yes, it will be 4, but that should be the principle. We will not add 2 plus 2 all the times. Is it clear? So here L equal to 2, S equal to 2. So if it was less than half filled, then we will write here J equal to 0. But since it is more than half filled, because half filled means there are 5 electrons, but here there are 6 electrons. So since it is 6 electron, it is more than 5 electron, that is more than half filled. So for more than half filled, the ground state is L plus S mod. So L is 2, S is 2, it is 4. Suppose it is there is only one electron present. So can anyone tell me, this is the this example we did. So suppose we will suppose there are only two electrons in this state. Can anyone tell me it is D? Can anyone tell me what should be the ground state? How and now just tell me how should I be proceeding? First I will calculate what? Ms. So for S equals to half, Ms is minus half and plus half. Since both the electrons are spin up, so it will be half plus half. So 1. So here Ms is 1, which corresponds to S equals to 1. And for L, when we calculate L, we will add, this is minus 2, this is minus 1, this is 0, this is 1, this is 2. So it will be only minus 2 and minus 1. So minus 2 and minus 1 will be how much? Minus 3, and this minus 3 corresponds to L equal to how much? 3. So here what should be the ground state then? What should be the ground state? Since S equals 1, 2S plus 1 will be 3, and for L equal to 3, the value of D for L equal to 3, what is the value of D? What is the value of L? What should be the S, P, D, F? So it will be F. And J will be how much in this case? Can anyone tell me? It will be not 4. Here, as you can see, it is less than half filled, and for less than half filled, J should be L minus S. It will be 3 minus 1, that is 2. Here, why it is 3? Why it is 3? This 3 corresponds to 3 values of J, so it will be 3F. 3 plus 1 4, 3 minus 1 2, so it will be 2 3 4. But here in this case the ground state will be 3F2, because since it is less than half filled, the ground state corresponds to the J value having the lowest J value, that is L minus S mod. So 3F2 will be ground state. But if in this case there are another case may be possible in the same. If there are how many electrons? There will be 8 electrons, suppose. 1 2 3 4 5 6 7 and 8, that is these two are unpaired, so it will be plus 2 and plus 1, is not it? S will be same. S will not be same, because here plus minus half cancel, plus minus half cancels, plus minus half cancels, and this is plus half and plus half is 1. So in this case S will be 1. Let me, and again for L, minus 2, here minus 2 minus 1 0, they will be cancelling. It will be how much? Can you not let me do it in a separate? Wait, let me do it in a separate slide, because then it will become. So it is 3D8. Suppose we have 3D8. 3D8 means there are 8 electrons present. So here S will be how much? These half plus half, plus half minus half 0. For this state it will be 0, for this will be 0. But for the lone pair states, it will be half plus half, that is 1, which corresponds to S equal to 1. Here again, if we calculate for L, what will be the value of L? L will be 3, because it will be minus 2 plus minus 1 plus 0 plus 1 plus 2, then again minus 2, then again minus 1, then again 0, because in these three states, minus 2 minus 1 0 1 2, they have 2 electrons, so they will be added twice. So these values cancel out, and the remaining is minus 3, and this minus 3 corresponds to L equal to 3. Here S equals to 1, L equals to 3, but the ground state will be how much? Ground state will be 3F. Anyone? 3F4, right? Because here it is more than half filled. So for more than half filled, the value of J will be how much? The value of J will be L plus S mod, or L plus S. So it is 3 plus 1 4. So what we saw here, is this 3F 2 3 4, they all corresponds to D2 also and D10 also, is not it? Because here it is D8 and here it is D2. So for D2 we will be having all these states like 3F2 3 4 and 3F2 3 4. But here the ground state will be, what will be the ground state for D2? It will be 3F2, but for, sorry, it is 8 not 10, it is 8, but it will be 3F4. Is that clear? Because it is more than half filled. but it is less than half filled. Is this clear to all of you? It is very important concept. So if you remember it, you can solve different problems you get in exam. Generally in GATE exams, this type of question I have also encountered this type of questions in NET exam. In NET, I think November 2020, the November 2020 or uh, November 19, November 2019, there was a question like this. The question was what should be the ground state. So it is easy to calculate, but only thing you should remember for ground state, the value of J will be L minus S if the state is less than half filled, and if the state is more than half filled, the ground state will be the highest value, that is L plus S. And from spectroscopic term, what we can also verify here that if the maximum number of electron present in D is how many? D can accommodate maximum how many number of electrons? Anyone? So D can accommodate 10 electrons. So if this is 10 and this 2 plus 8 is equal to 10, so like in the question, what we found, in videos we must have seen the spectroscopic term corresponds to D2 and D8 should be same, but the difference is in ground state, because for this state the ground state 3F2, but for D8 the ground state is 3F4 because it is more than half filled and it is less than half filled. So this is a basic difference between the ground state of more than half filled and less than half filled states. So everyone is clear about this problem? Anyone? Yes. Z equal to 26. Here you are saying no. It's why it should be ground state will be how much? 5D 0. No, no, 5D 0. How it will be 5D 0? Because there are 6 electrons here. 6 electrons means it is more than half filled or less than half filled. No, how it is less than half filled? Half filled means the capacity of D is 10 electrons. Is it okay? The capacity of D is 10 electrons. So D can accommodate 10 electrons. But if there are 5 electrons, that is each cell has 1 electron, then it is half filled. Since 10 is the maximum value, any number greater than 5 is more than half filled, and any number less than 5 is less than half filled. Now you clear about it? Hello, can you hear me? So now you got my point, because here 3D6 means it has more than 5 electrons, and for more than 5 means it is more than half filled, and for more than half filled the value of J is L plus S. For less than half filled the value of J is L minus S. Should I write it somewhere? Let me write it here in a, yes, here I can write, if it is more than half filled, J will be L plus S. If it is less than half filled, J will be L minus S. Is it clear now? Okay, so we should go to the next question. The next question is certain excited state has an atom that has electronic configuration of 4d1 and 5d1. What are the possible L and S values? So here we should calculate. What should we calculate? Here we calculate the LS coupling terms. What will that will be coming out of the electrons electronic configuration of 4d1 and 5d1. Can anyone tell me this 4d1 and 5d1 are they equivalent electrons or non-equivalent electrons? Because this is one electron and this is another electron. Can anyone tell me what? Uh, Leave it. Just tell me what is equivalent electron and what is non-equivalent electron. Anybody? Anyone can anyone tell me what is equivalent electron and what is non-equivalent electron? We had discussed it in previous session. The equivalent electron is the equivalent electrons are they for which the value of n and l both are same. But here for this electron the value of n is how much? 4. But here the value of n is 5 because it is 4d and it is 5d. Then these are non-equivalent electrons, is not it? Hello, please respond to my questions. So, can anyone again tell me what is equivalent electrons? If yes, if two electrons have same L and S values, then they are equivalent electrons. Suppose in question it is given 4d2. Then here there are two electrons also present, but here for this electron n is 4, for this electron n is 4, for this electron also since both are present in D, here L is 2 and here also L is 2. So here the two electrons are equivalent electron because they have same L and S values. Sorry, N and L values. But here the N value is different. N value is for one electron N value is 4 and another electron is N value is 5. So this is non-equivalent case. So it is non-equivalent case. Is it clear to all of you? So, in equivalent case, there was a trick because according to Paulus exclusion principle, no two electrons can have all the four quantum numbers same. So here, out of possible combination of L and S values, we were not taking all combinations because some of the combinations from L and S, if we take them, then they will not obey Paulus exclusion principle. But here, since it is non-equivalent electron, we can directly calculate different states. Possible or a possible L and S values we can easily calculate. So for non-equivalent electron, it is 41 and 5d1. So S1 is how much? S1 is half and S2 is also half. So what is S? Half half. The vector addition of half half will be how much? S will be One will be half plus half, and another will be half minus half. Like if we have this is half, then it is plus half, it is 1. But if one is up and another is down, then it will be plus half and minus half equal to 0. So it will be 1 and 0. Is this clear? Anyone? So the two electrons having spin half and half give rise to the combinations of spin AC is equal to 1 and 0. Similarly, for L value, here it is D. What is the L value for D? Here L1 will be how much? 2. L2 will be how much? 2. And corresponding to these two, what? Please tell me what should be the value of L then? Like in the previous case, half and half gave us 1 and 0. So here 2 and 2 will give us, what will they give? No, not 4 comma 0. It is 4 2 0, like 4 3 2 1 and 0. Because if we are adding L1 plus L2, then the resultant L will be L1 plus L2, L1 plus L2 minus 1, L1 plus L2 minus 2, like that up to L1 minus L2 mod. All these will be mod. Is not it? So the value of L corresponding to L1 equal to 2 and L2 equal to 2 is from 0 to 4. That is 2 minus 2 is 0 and 2 minus 2 plus 2 is 4. So it is 4 3 2 1 0. So all 5 values of L is possible, and two values of AC is possible. So when you calculate the number of terms, L will be 4 3 2 1 0. S will be 1 1 1 1 1. Again, this is S, this is L. Then again for S equal to 0, L will be 4 3 2 1 0. S will be 0 0 0 0 0. So can you tell me, for L equal to 4 and S equal to 4, what should be the J value and what should be the term? Can anyone tell me? This 4 plus 1 will give which J values they will give? Anyone? So for L equal to 4 and S equal to 1, the possible J value is from 4 minus 1 to 4 plus 1. So 4 minus 1 is how much? 4 minus 1 is 3, 4 plus 1 is 5, so J is 3, 4, 5. Similarly, the spectroscopic notation then will be how much? Since S equal to 1, it will be 2S plus 1 will be 3, and L is 4, 4 means S, P, D, F, G, 3G, it is 3, 4, 5. 3G, 3, 4, 5. Similarly, here in this case, it is 3 plus 1. They will give 4 to 2. They will give 2, 3, 4. It will give 1, 2, 3. It will give 1 plus 1 is how much? 1 plus 1 is 2 and 1 minus 1 is 0. So it will be 0, 1, 2. And here it will be only 1. And here all this case it will be 4, because 4 plus 0 is 4, 3 plus 0 is 3, 2, 1, 0 plus 0 is 0. and the corresponding value of g will be for l equal to 3. For all these s equal to 1, so 2s plus 1 will be 3, so it will be 3f 2 3 4. It will be 3d 1 2 3. It will be 3p 0 1 2, and it will be how much? 3s 0, because here it is only 0, and here it is how much? It is 4, it is 0, so it will be 1 g4. It will be 1 f3. It will be 1 d2, 1 p1, 1 s0. Is this okay? So these are the possible terms we will be getting for an atom having electronic configuration 4d1 and 5d1. Did you understand all these terms? How I calculated the value of s? I first I take the value of s, and then value of l, different value of combinations of l and s, because here l has 5 values and s has 2 values, so the number of combination will be 10. 5 into 2 10. So first we vary l, and s is 1, then we vary again l for s equal to 0. So there are 10 combinations, and these 10 combinations give these spectroscopic terms. Is this clear to all of you? So we will discuss more problems in the next session. So thank you all for attending today's session. I am stopping it here. Thank you.